All right, so what we're going to do this time basically is we're going to compute a limit or state why it does not exist. This one is being a little bit more mean. Sometimes in the book or when they do an example like this, if they're going to give something similar to this or this one possibly, they might give you a one-sided limit at first. This one I'm doing for myself and showing in the video how to not catch yourself. But this is going to zero, so from both sides, but I see absolute value, and I know absolute value at zero, which is where I'm going, has different values. So let's recall first again, absolute value is defined as itself if you're non-negative. Again, as always, he's the guy at the party. We're at a party, calculus party. He's the guy going around at the party saying, are you non-positive or at least not negative? If you are, then you can be yourself. If you're being negative, he throws a negative at you. He's handing out, I don't know what he's handing out at the party, but he's handing out stuff and it makes you positive again. So this is absolute value X. He gives you a negative. This is not a negative expression. Absolute value is always positive. So that negative means that this thing is now positive. So in my mind, because I'm more familiar and comfortable with absolute value and I know everyone hates it and so does your instructor, and that's why they give you limits with it in there. This is what you do first. Absolute value, my mind sees as different when I approach zero from different sides, and that's what we're doing. So the first move immediately is I'm going to split this to left-hand limit and right-hand limit and see what happens with both. And if they're equal, I'll say exist. If not, we say does not exist. So how do you do that? You get a plus on there. That's editable. So now we got a plus. What we're going to do with that is that plus now gives me an inequality. It says x is larger than 0. X is approaching 0, but from above. So x is larger than 0. So that says the absolute value of x is equal to itself as I approach, sorry, frog. As I approach 0 from above, x is larger than 0, so the absolute value of x is this, and that's how you strip off the absolute value bars. I can now write that as the limit as x approaches 0 from above of 1 over x minus 1 over x, because that is actually x when I approach from above. And now that is 0. So that becomes the limit as x approaches 0 of 0, which is 0. So again, what is that? The right-hand limit is equal to 0 of this function. That's syncopated algebra. I've used letters and algebra in the equation. So now I compute the left-hand limit. The left-hand limit is going to give me, let's just remember this, the limit as x approaches 0 from above of 1 over x minus 1 over absolute value x was 0. Now let's approach from below. Now what that's saying is, again, I'm at 0. X is approaching 0 from below. So that tells me immediately x is less than 0. When x is less than 0, that says the absolute value of x is negative x. And so what is that going to give me? That's going to give me equals the limit as x approaches 0 from below. That analysis allows me to get rid of the bars in my limit now. That gives me 1 over x minus 1 over negative x. And I be careful with the minus. These two minuses cancel to give me a plus. So now what's going to happen is I just erase what I tried to keep in the memory. It's 0. Keep it in your short-term memory. The limit as x approaches 0 from below is now 2 over x, these combined. When x is less than 0, this approaches negative infinity. Why? 2 is positive, and x will be less than 0, so negative when I approach 0 from below. So what does this say? The left-hand limit is equal to negative infinity. This seems bad. The limit doesn't exist. So let's recapitulate that. Oh, coffee everywhere. Someone's excited. That's coffee abuse. Coffee abuse. The left-hand limit is equal to the limit as x approaches 0 from below of 1 over x minus 1 over the absolute value of x, which we found was, I'm abusing the notation, equals negative infinity. And then the right-hand limit is equal to the limit as x approaches 0 from above of 1 over x minus 1 over the absolute value of x, which was equal to 0. Therefore, the left-hand limit equals negative infinity, which does not equal 0, which equals the right-hand limit. And what do? We have a theorem always that says the left-hand limit is equal to the right-hand limit if and only if the limit exists. So the left-hand limit did not equal the right-hand limit. Therefore, this limit does not exist. I don't know how the editor is going to use that, so I'll do that one more time. The left-hand limit is equal to negative infinity, which is not equal to 0, which is equal to the right-hand limit. Therefore, the limit as x approaches 0 of 1 over x minus 1 over the absolute value of x does not exist. That's how you drink coffee. That's a cement floor. Careful. I just spilled coffee all over myself being a jackass. Wardrobe. So, I don't know how any of that crap works, but apparently below here somewhere is a subscribe button or a bell or one of those things that you're supposed to do. Like my videos, please subscribe to the channel. I'll see you next time.